So in this video, we're going to take a look at what's happening with the y values with exponential functions and how that affects where our asymptote is and if it moves or not. So let's start with our parent function, y equals 2 to the x, and plug in some values for x. So when we plug in -2, we get 2 to the -2. That -2 exponents means we have to put that down on the bottom of a fraction, and we get 1 over 2 squared, which gives us 1/4. And we get a similar thing when we plug in -1. We get 1 over 2 to the 1, which is 1/2. 2 to the 0 gives us 1. 2 to the 1 gives us 2. And then 2 squared gives us 4. So what this does is it gives us 5 points that sit on the graph of this function. And I've got it graphed down below here. Show it here. So it is the black graph. This is y equals 2 to the x. And I'll maybe graph this in red here. So the 3 points that we found were -2, 1/4, -1, 1/2, 0, 1, 1, 2, and then 2, 4. So we can see those points on our graph. Great. So then looking at y equals 1/3 times 2 to the x, how I said that there actually is pretty important. When we plug in -2, looking at our order of operations, we have to do that exponent first before we do our multiplication. So we're going to get 1/3 times 1/4, because that's what 2 to the -2 is. We just did that right over here in our original table. So that's going to give us 1/12. And then 1/3 times 2 to the -1 is going to give us 1/3 times 1/2, so 1/6. 1/3 times 2 to the 0 is going to give us 1/3 times 1, which is 1/3. 1 times 2 to the 1, or 1/3 times 2 to the 1, sorry. There we go. That's going to give us 1/3 times 2. It's going to give us 2/3. 1/3 times 2 squared. It's going to give us 1/3 times 2 to the 4th. 2 to the 4th, 2 squared. This is going to give us 4. There we go. My brain and my pen are kind of not working in coordination this morning. So again, what we've got are 5 points that are on our graph. So -2, 1/12, -1, 1/6, and so on. And we can see down here on the purple graph, those points. We've got -2, 1/12. It's, all pretty close to the y-axis there. We've got -1, 1/6, 0, 1/3, 1, 2/3, and then 2, 4/3. So we're seeing those points, and basically what happens is when we multiply by 1/3 is it takes all of our original y values. So you notice we've got all of the original y values that we had from our parent function, and they all got multiplied by 1/3. And what that did is it squished them all down. It compressed this graph. This is something you'll learn more about in Math 111, but we can really kind of see what's happening here, that it's squishing down that graph. Now, if we change and multiply it by something that's bigger than 1, like 6, what's going to happen is that we're going to get, when we plug in -2, we're going to get 6 times 2 to the -2. So we're going to get 6 times 1/4. So we get 6/4. And that is going to get, we can reduce that if we want, but that's going to give us, 3 over 2, so 1.5. And then we're going to get 6 times 2 to the -1, so we get 6 times 1/2, which is 6/2, so that's 3. 6 times 2 to the 0, which is going to give us 6 times 1, which gives us 6. 6 times 2 to the 1. Oh, this is probably going to be off of our graph. That's going to be 12. Yeah, I did not make my scale quite that big. But you can see this time it took those y values and multiplied again each of our original y values by 6. So it stretched it out. And again, we can see those points here on our graph. So there's -2 and 1.5. There's -1, 3. There is 0, 6. And then if we continued on up here, if this graph kept going, we would get to that 1/12 and that 2/24. I just didn't draw that scale big enough there. But what's happening here is this is taking these points and stretching them up taller. So what's not moving is our asymptote. Our asymptote is staying put at y equals 0. And that's because no matter, if we multiply by this number out in front or we don't, what's going to happen when we plug in these negative x values is we're going to keep getting smaller and smaller fractions from our exponential part, from this part that's 2 to the x. We're going to get things like 1/2 and 1/4 and 1/16 and 1/64. And they're going to keep getting smaller and smaller, even if we're multiplying it by a third, or even if we're multiplying by 6. It's going to take us a little longer with this blue graph to get towards our asymptote, but that asymptote is still going to be there. We're going to get closer and closer to our y values being 0, but we're not actually going to get there. And the other thing to notice about this, because of our multiplication here, is that our y-intercept ends up being that number that we're multiplying by out in front, because anything to the 0 power is 1. So when we, no matter what our base is, if it's 2, if it's 7, if it's 1/7, when we have it to the 0 power, we're going to get 1 right here, and it's going to be multiplied by that number out in front. So if we're multiplying by a number out in front with our exponential, that's going to be our y-intercept. So kind of to sum up things here, if you've got an exponential that's a times b to the x, 0a is going to be your y-intercept, not intercepts, intercept, and our asymptote is going to be at y equals 0. So the only thing that's going to ever move that asymptote and where it sits from y equals 0 is if we move our graph up or down. So again, we've got our parent function here, and I can fill this table out really quickly because we just did it on the previous slide here. And so when we're doing 2 to the x minus 3, what's happening there is that we've got to do that subtraction before we make that our exponent. So we're going to get 2 to the negative 5, which, oh man, now I got to remember what 2 to the 5th is. And that's the 32nd. So this is 2 to the 32nd. And if we do this here, we get 2 to the negative 4, which I believe that is 1/16. Yep, it sure is. 2 to the 0 minus 3, we get 2 to the negative 3. That's going to give us 1/8. 2 to the 1 minus 3, that's 2 to the negative 2, which is going to give us a 4th. And then 1 minus 2 minus 2 to the 3rd is going to give us 2 to the negative 1, which is 1/2. So what happens here when we have this shift, right, which hopefully we know, after week 3 looking at this, that's going to shift our graph to the right. The reason why that happens is that we get to all of our x values later. Like it took us a while to get to 1/4 as an output. And it took us a while to get to 1/2 as that output. It took us, go do it this way, 1, 2, 3 units later. So 3 units later to get to that. So all of these points got shifted 3 units to the left. But what didn't change is where our asymptote is. It's still, as we plug in bigger and bigger negative numbers, our y values are getting smaller and smaller. I mean, we can really see it here on this one, that if we plugged in -4 and -5, we're going to get numbers that are even closer and closer to 0, just smaller and smaller fractions. So again, that still doesn't move our asymptote. The only thing that's going to move that asymptote is if we take our graph and shift it up or down, right? And we know that this is going to take it down of 3 units. And this is done after we do our exponent. So again, that's that order of operations there. Make my handwriting a little better here. That it's telling us to do 2 to the negative 2 and then subtract 3 from that. So we end up with 1/4 minus 3. Oh man, now I'm gonna have to do some fractions here. So we get -11/4. And 2 to the negative 1 minus 3. So 1/2 minus 3. So 1/2 minus 6/2. So we get -5/2. 2 to the 0 minus 3. This one's going to be a little easier to see because it's going to be the movement of our y-intercept. So we get 1 minus 3 -2 is what we get there. 2 to the 1 minus 3. So we get 2 minus 3, which is at -1, and 2 squared minus 3, which gives us 4 minus 3. And then that gives us 1. So again, what we're doing is we get those same y values, but each time we're subtracting 3 from it. So that's taking all of our y values and moving them down 3 units. So what also happened is that asymptote then moved down 3 units along with our graph. And so that's the only thing that's ever going to move our asymptote is if we have that shift up or down. And, generally, sort of in a basic parent function exponential, where it's just 2 to the x and that's it, or 3 to the x, or 7 to the x, or 1/7 to the x, where our y-intercept is and where our asymptote are, they are going to be 1 unit apart. But when we start shifting things left or right, that does change because our y-intercept here is right there. It's not 1 unit from our asymptote. Our asymptote still is there at 0. And back up here, again, on that parent function, we're 1 unit from our asymptote, but not when we compressed our graph, and definitely not when we stretched out our graph. That moved where that y-intercept is. So, you can always find a y-intercept of any function by plugging in 0 for x. That's always going to tell you where that is. And your exponential functions, your asymptote's always going to be at y = 0, unless you shift the whole thing up or down.